All right, here we have lesson 4, the sine and cosine ratios. So we have looked at the tangent ratio, and the sine and cosine ratios should come pretty naturally to us as we have learned to work with that type of formula. So here we have the sine of angle A, written as sine A, is the ratio of the side opposite angle A, side A, to the hypotenuse, side C. And the ratio that we'd use for cosine, if we have the cosine of angle A, in this case cos A, is the side adjacent to the angle side B to the hypotenuse, which would be side C. So here we have sine theta is equal to opposite over hypotenuse, and if we were to identify it in a triangle, it'd be A over C, while cos is equal to adjacent over hypotenuse, which would be B over C. Now you may have heard this before, but the three ratios, tangent, sine, and cosine, are often referred to the primary trigonometric ratios, and to remember these, we use the acronym SOHCAHTOA. So SOH, sine, is equal to opposite over hypotenuse. Cos is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. So now let's look through some examples to practice using the sine and cosine ratios. Example 1, determining the sine and cosine of an angle. So the triangle DEF, so as we have here, DEF, identifies the side opposite angle D and the side adjacent to angle D. Determine the sine of D and the cos of D. So let's start. Sine D is equal to, so SOH, so sine is equal to opposite over hypotenuse. So let's look at angle D. We have opposite over hypotenuse. So in this case, it is 5 over 13. Now let's look at what would the cos of angle D be? Cos is adjacent over the hypotenuse. So if we're looking at angle D, we're looking at the adjacent, so that's 12 over the hypotenuse, which is 13. So that's how we would set up the ratios. We're going to use inverse sine and inverse cosine, just like we did for tangent. So here we have the inverse of sine. So you want to find the sine button on your calculator, shift or second function to get the inverse of 0.8976. And we would get 63.8 degrees as our value. If we're looking at the cosine, we want to use the cos function and use inverse cos, so second function or shift, open bracket, 3 divided by 4, close bracket. And this would give us 41.1 degrees. Using cosine or sine to determine the measure of an angle. So here we have a triangle, and it wants us to determine the measures of angle G and angle H to the nearest tenth of a degree. So let's start with angle G. So we have, let's find the cos of angle G. So cos of angle G is equal to adjacent over hypotenuse. So if this is angle G, we have our adjacent, which is 6, over hypotenuse, which is 14. So we have 6 over 14. Now we're solving for an angle, which means we need to use the inverse cos of open bracket 6 divided by 14, close bracket, to solve for the angle, which would give us 65 degrees. Now let's solve for the sine of angle H. So this here's angle H is just cut off a little bit. So sine of H is equal to opposite over hypotenuse. So the opposite value is 6 over the hypotenuse, which is 14. So we have sine H is equal to 6 over 14. We're solving for an angle, so we need to use the second function for inverse sine, 6 divided by 14 close bracket, to give us 25 degrees. Now notice, our values were the same, 6 over 14. However, the sine compared to the cos ratio gives us two very different answers. Example 4, using the sine or cosine ratio to solve a problem. So here we have a 10-foot ladder leans against the side of a building with its base 4 feet from the wall. What angle to the nearest degree, so it's asking for a whole degree, does the ladder make it to the ground? So let's draw a little diagram. Here we have a building. There is a ladder that's leaning up against this building. There's the ground. Now the ladder is 10 feet long, so it's leaning up against the building. This is obviously not drawn to scale, but the base of the ladder is 4 feet. And here we would have our right angle. It wants to know at what angle does the ladder meet the ground. So it wants to solve for this angle here. Now I need to determine if I'm going to use sine or cosine. So if this is my angle that I'm trying to solve, I have the adjacent and the hypotenuse. So in this case, I'm going to be using cos. I'm going to call this angle here x. So I have cos x is equal to the value of adjacent over my value of hypotenuse. Cos x is equal to 4 over 10. Solving for an angle, I need to use inverse cos, open bracket, 4 divided by 10, close bracket, to give me an angle of 66 degrees. So the ladder makes a 66-degree angle with the ground. There we are. Please look for the practice questions in the OneNote on lesson 4 using sine or cosine.